All right, so in this video, what we're going to be doing here is we're going to be looking at powers of monomials. All right, so first thing I want to point out is what a monomial actually is. So it is this right here. So negative 2x squared y to the 7th. This is an example of a monomial. So the negative 2, it's got a name to it. It's called a coefficient. The x and the y are called variables. And the 2 and the 7 are what we call the exponents of the monomial. Okay, so that's just kind of like the pieces of what's called a monomial, right? The different parts to it. All right, so let's take a look at this example. I want to take negative 2x squared y to the 7th, the third power, right? And we want to simplify it. Okay, so I'm going to show you two ways to simplify it. The first way I'm going to show you here is kind of like the logical kind of steps that you would do just to kind of show it the logical way. And then what I'm going to do the second way around is I'm just going to show you kind of a quicker way to get the answer. Makes sense, right? So let's take a look here. So negative 2x squared y to the 7th, if it's raised to the third power, that means that we're actually going to take this negative 2x squared y to the 7th, multiply it by itself 3 times, right? So that's the definition of the exponent. Okay, so this thing here, negative 2x squared y to the 7th to the third power is the same as multiplying that monomial, which is in the brackets, by itself 3 times. Okay, so once you've done that, basically what we're doing is we're multiplying these 3 things together, but each one of these monomials has 3 items to them. And so basically what we're actually doing is we're multiplying 9 things together. And when it comes to multiplication, we can kind of reorder the order of multiplication. So what I mean by that is that I can write this actually as negative 2 times negative 2 times negative 2, since there's 3 of them, times x squared times x squared times x squared times y to the 7th, y to the 7th, y to the 7th. All right. And yeah, so negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. Okay, so basically what I did is I just combined these 3, multiplied these 3 together, and I got negative 8. Next up, if I was to multiply x squared times x squared times x squared, if you recall from the previous lesson, or previous couple lessons, the rule is to add your exponents. So this is x to the 2 plus 2 plus 2, which is 6. And likewise for the y's, I would add these exponents, 7 plus 7 plus 7, which is 21. Okay, so this is this expression here simplified. All right, so this kind of hopefully gives you kind of a visualization as to what's happening. Now that being said, this other way that I'm going to show you how to get the answer, go from here to here, is the one that you'll probably get used to doing. All right, so let's try it again. So I'm just going to write it up again. Negative 2x squared y to the 7th cubed. All right, so rather than writing this out 3 times, what you can actually realize is that if we look, if you look here, right, and just kind of ignore this first line. If I look at the second line, the negative 2 is being multiplied by itself 3 times. So in other words, this 3, I can actually, in a way, kind of bring them in. That makes sense, right? And so this is going to equal. Black. All right, so this is going to equal negative 2 to the third power, x squared to the third power, y to the 7th to the third power. Okay. So again, negative 2 cubed is negative 8. And remember that the rule for when you have an exponent outside of an exponent is you're going to multiply them together. All right, so x squared to the third power is x to the 6th. Likewise, y to the 7th power cubed is y to the 21st. And what you'll notice is that, yeah, we got the same answer as before. Okay, so this is a little bit quicker. So basically, whenever you have a power outside of the monomial, you're basically raising each one of those terms to that power. Okay, cool. All right, so let's try another one. Now this one's a little bit more complicated because you'll notice we have two monomials. Right? So now when we have this, notice the first one here is not raised to any power, but the second one is. And according to BEDMAS, we actually have to do exponents before we do any division or multiplication. So what that means is that we need to actually look at this. I'll simplify the second one first because this exponent, this monomial is being raised to the fourth power. Okay. So this is going to equal, let's see, I'm just going to write the first monomial here in the brackets. But the second one here, and if I apply that, this is going to be, and actually what I'm going to do is I'm going to take this 4 and raise each one of these three items here in the second monomial to the fourth power. All right, so when I do that, I get 3 to the fourth power times x to the 4 times 4, which is 16, and y to the 2 times 4, which is 8. Okay, so basically this exponent, the 4 here, brought it into this monomial. All right. Now what? All right, so next up, I'm actually just going to simplify 3 to the 4th. I could use a calculator, or I can realize that 3 to the 4th is 3 times 3 times 3 times 3. Well, 3 times 3 is 9. And 3 times 3 is 9, so this is 9 times 9, which is 81. Okay, so this one here is 81. And again, I still have x to the 16th, y to the 8th. All right, so now we're doing multiplication. So first thing I want to do is I want to multiply the negative 2 with a positive 81. That is negative 162. And then when it comes to variables, when I'm multiplying variables with the same base, I add the exponents. Now this x, the first one, you'll notice there's no exponent there. So it's actually to the first power. Okay, so I need to add this one with the 16, and as a result, you get x to the 17th power. And then likewise, I'm going to go y cubed times y to the 8th is, if I add the exponents, y to the 11th. This is actually the simplified version of this expression here. Cool. So hopefully that makes sense. I think I got one more example here. So this time we have kind of a fraction, right? Monomial on top of monomial. This is, first thing I'm going to do here, I'm similar to that first example. I'm just going to write it out. So, okay, so this thing squared is going to equal 2 to x to the 4th over 3y squared. Well, squared, which means I'm going to multiply it with itself twice. It's being squared. And the rule for fractions is that you multiply the tops together, and then you multiply the bottoms together. Right. So as a result, this is going to equal, so 2 times 2, which is 4. I have x to the 4th times x to the 4th, which is x to add the exponents together. Right? Same base, that's x to the 8th over, now 3 times 3, which is 9. I have y, add the exponents together, I get 4. Okay, so this is the kind of like the final answer. Right? Now, rather than writing it out twice, right? So sometimes this will be like to the 8th power. We don't want to write it out 8 times. The other way that we could do this first is we can actually take this exponent and raise these, there's 4 of them, right? 4 items here, that power. Okay, so if I was to do that, this is going to equal 2 squared over over x to the, and the rule is, again, of an exponent outside of an exponent, so multiply them together. X to the 8th over 3 squared. Multiply that, multiply the y, the 2 with the 2, so that's y to the 4th. So this is going to equal, and 2 squared is 4. So I have 4x to the 8 over 3 squared, which is 9, y to the 4th. And you'll realize that it's the same answer as you got before. Okay, so whenever you got fraction over fraction, basically you just want to take each of the individual terms or items and raise it to that power. All right, guys, so those are, powers of monomials.